Hi everyone, and this is Sandeep. You are watching Samyans Academy, and in this session we are going to discuss about chemical reactions and equations. Let us start now. So chemical reactions means the breaking and making of bonds between the different atoms to produce new substances called as chemical reactions. So in chemical reactions, reactants are going to break and products are going to be formed. So there are two types of changes, namely we have here physical changes and chemical changes. Example for the physical change is melting of ice, and the rusting of iron is a example for chemical change, and formation of curd is a example for the chemical change. And what are the differences between the physical change and chemical change? And physical changes are the temperature changes, and chemical changes is permanent change. It cannot be reversed. Chemical change cannot be reversed, and physical change can be reversed. This ice is converted into liquid water, and water is converted into vapor. Vapor again converts to water. Water again freezes to ice. So in the physical state, the component and the chemical composition is not changing. Only the state of the matter is reversing it. And in this physical change, energy may not be or may be released or absorbed. In the chemical change, energy is released or absorbed. And these are the differences between the physical change and chemical change. Now you see, in the chemical equation, so in the chemical equation we are representing here symbols, and these are the reactants. Reactants we are representing with the formulas, and products also we are representing with the formulas. Here we are keeping one arrow mark in between them. And this represents the chemical equation. If chemical equation represents with the word is, that is magnesium, you are writing the words, this oxygen gives rise to magnesium oxide, and this is called as a word equation. In the right hand side, I have to write the reactants, and the left hand side, we have to write the products. Sorry, left hand side, you have to write the reactants, and the right hand side, you have to write the products, and you have to separate the reactants and products with the arrow mark. Now you see, what is balanced equation? Now you see the same number of atoms of each element on the left hand side, or reactant side, or right hand side, or product side of the equation we call as a balanced equation. So when you observe this chemical equation, here we have the magnesium plus O2 plus MgO. Now you observe here magnesium on the left hand side we have only one element, and the right hand side also we have the one element. And oxygen on right hand side we have two elements, and oxygen on left hand side only one element. To balance the oxygen, so what you have to do here? So just you have to put the 2 beside magnesium oxide, right? Now you see, now you compare here magnesium atom becomes 2, and here 2 mg. Now you see, when you compare this, 2 mg plus O2 gives rise to 2 mgO. Now it is balanced equation. Okay. Now when you compare this, chemical equations are examples. Next example here we have. So while doing the balancing the equation, first you balance the maximum number of atoms with the element. So here oxygen is Fe3O4. Here we have the 4 oxygen atoms, right? Now you see, here iron is there plus H2O. Here we have the Fe3O4 plus H2. Now for balancing the equation, first you have to observe which one is in the maximum number. Which one is maximum number here? Oxygen is the maximum number. How many oxygen atoms we have here? 4 oxygen atoms. Now you balance this first. First you balance the oxygen atom. So to balance the oxygen atom, just you keep the 4 beside the water molecule. Now you compare the hydrogen atoms. Now here we have the 8 hydrogen atoms on the reactant side, and only 2 hydrogen atoms on the products. To balance the hydrogen atoms, I am keeping your 4 coefficient beside the hydrogen. Now you see the balance hydrogen atom is balanced. Both side it is 8. Now you see, here we have the 3 iron atoms, but here we have only one iron atom. To balance this, you keep just 3 iron here, right? So this is the balanced equation. Now you see, next yeah, this is the balanced equation. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Right. Informative equations is the representation of physical state. Okay. When reactants are product which are in solid state or liquid state or gaseous state, the solid state represented with the S letter. Liquid state we represented with the L letter, and gaseous state we represented with the G. So above arrow mark indicates evolution of the gas, and water soluble substance we have to represent with the AQ. AQ means aqueous, the salt present in the water. Precipitate we have to represent with the S, and downward arrow mark indicates it's the precipitate. So solid precipitate is formed during the chemical reaction. And reaction conditions such as temperature, pressure, catalyst indicate above or below the arrow. And here we have some examples for the informative equations, right? Right. So here we have the informative equations. Now you see, when iron reacts with the water, now iron is in solid state. Iron is solid state. Water is in liquid state. You represent with the L. Iron will represent with the S. Right. When you give rise to, and it it forms Fe3O4. This is rust. It is in the solid form, and the hydrogen is the gaseous state. You have to put here G, and liberation of the gas we have to indicate it with the upward arrow mark. Okay, and here carbon monoxide, when it is react with the hydrogen gas in atmospheric 340 atmosphere, here reaction conditions also we are mentioning above the arrow mark. That is the pressure we are maintaining 340 atmosphere. Due to that pressure, the carbon monoxide and hydrogen gas come close to each other and form methanol. So the formation of methanol in liquid state, you have to represent it with the bracket in L. Now this is the formation of this is the photosynthesis reaction. In this photosynthesis reaction, the carbon dioxide which is in the aqueous, this is a soluble form. It is reacted with the water. It is in liquid state, and the reaction conditions are these reactions are carried out in sunlight and presence of chlorophyll, and it will form glucose 6C6H12O6 plus 6O2 plus 6H2O. And these 6 oxygen molecules are in aqueous state and 6 water molecules in a liquid state. And this is a photosynthesis reaction. And types of reaction we have here: combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation, reduction, redox reaction, dispersion, exothermic, and endothermic reaction. And these are the types of reactions. Okay, and here combination reaction, a reaction in which two or more reactants combine to form a single product is called as combination reaction. Okay, here we have how many reactants we have here? Two reactants. These two reactants and combine carbon plus oxygen and form one single product, that is carbon dioxide gas. So this is the example for the formation of carbon dioxide gas, is the example for the burning of coal, is example for the combination reaction. Next, to formation of water from the hydrogen and oxygen gas. When you combine this hydrogen gas and oxygen gas, then it will form the water which is in the liquid state. Here two reactants, hydrogen gas and oxygen gas, combine and form as one single product, and this is we called as a water, which is a formation liquid state. And now here we have the formation of Slagle lime. Slagle lime means it's a dry powder, that is a calcium oxide, is in solid state, and it is when it is combined with the water, that is H2O, and it will form Slagle lime calcium hydroxide, which is in the aqueous state, right? So this is a Slagle lime calcium hydroxide. Now you see decomposition reactions here. A reaction in which a single reactant breaks down to two or more product is known as decomposition reaction. In this, now you see, observe this reaction. Here is iron sulfate is a single reactant, and when you give the heat, so it decomposes into two or many substances, two or three substances. Now it is formation of the Fe2O3, SO2, SO3. Now these single substances converted into many or two or more, and then dissociated into two or more substances, and which is called as a decomposition reaction. So in this, what happens here? Single reactant breaks down to form three products here. What are the products we got here? Ferric oxide, sulfur dioxide, and sulfur trioxide. Now you represent the states here solid. Here also you represent with the bracket S. This is all sulfur dioxide gaseous product, and this is the sulfur trioxide is the gaseous products. Okay. Now this is the decomposition reaction. Thermal decomposition means, and these reactions are carried out in the presence of heat. We call it as thermal decomposition. And these reactions are how many types? Thermal decomposition reaction, photolytic decomposition reaction, and electrolytic decomposition reaction. In thermal decomposition reaction, and these reactions taking place in the presence of heat. Here iron sulfate in presence of heat is decomposed into Fe2O3, that is we call as ferric oxide, and also we call as rust. And along with this we get these gases, sulfur dioxide gas and the sulfur trioxide gas. Now here we have the limestone. When you heat the limestone, you will get calcium oxide, that is we call it as the kick lime, and it decomposes into carbon dioxide. Means calcium carbonate decomposed into two substances. Those are calcium oxide and carbon dioxide gas. Now lead nitrate. So PbNO3 taken twice. This is the lead nitrate which is in the aqueous state. So when it is decomposed, it decomposes into lead oxide, nitrogen dioxide, oxygen gas. Just you remember this balancing equation 2241. 4 moles of nitrogen, 1 mole of oxygen, 2 moles of the lead oxide, and 2 moles of lead nitrate. Just you balance the equation and you leave it. Okay. Here we have the three reactions, and these reactions are carried out by heat. So what is the first reaction? FeSO4. When you decompose FeSO4, what are the products you will get here? Fe2O3, sulfur dioxide, and sulfur trioxide. And when you decompose calcium carbonate, what will you get the product? So what will you get? Calcium oxide, that is a lime. What is that? Name is pitch lime. It is in solid state, and also carbon dioxide gas. And when you decompose the lead nitrate in presence of heat, this lead nitrate decomposes into lead oxide, nitrogen dioxide, and oxygen gas. Okay, this is the reaction of thermal decomposition. Now you come to your photolytic decomposition reaction. This is an example for the photolytic decomposition reaction, and these reactions are carried in presence of light. So in this we have your silver chloride. Silver chloride in presence of sunlight it decomposes into silver and chlorine. You will get the gray color silver. So it's a white color powder. When you keep in sunlight for several hours, it turns into gray color, and there is a liberation of the chlorine gas. And this is a silver bromide in presence of sunlight. It decomposes into silver and bromine gas, right? Silver solid in state and bromine in gaseous state, right? Now, and these reactions are carried by sunlight. We call it as photolytic. Now, come to your electrolytic decomposition reaction. So here we are taking the water, okay, keeping two electrodes, cathode and anode. At cathode, you will get the 2 times hydrogen gas and 1 times of oxygen gas at anode. Okay, at cathode, hydrogen gas is liberated. At anode, oxygen gas is liberated. Here, volume of the hydrogen is 2 times more than compared to the volume of oxygen. Okay, this is a decomposition, and this water molecule is decomposed into hydrogen and oxygen in presence of electricity. We called as electrolytic decomposition reaction. Okay, and here we have displacement reaction. In this displacement reaction, one more reactant is displaced, one less reactive from that compound is called as displacement reaction. When a more reactive element displaces less reactive element from its compound, it is called as displacement reaction. Here which one is a more reactive? Iron is a more reactive. And which one is less reactive in this compound? Copper is the less reactive in compound copper sulfate. Here iron is displaced by copper. So copper is displaced by iron and form iron sulfate, that is aqueous. This is a copper. So copper sulfate, what is the color of the copper sulfate? Blue in color, right? When you keep make this copper sulfate solution and keep iron nails for 2 or 1 or 2 days or 24 hours to 48 hours, you keep it for that. This copper sulfate slowly turns into light green color. Finally, it comes to thick green color. And this iron nail deposited by copper means this iron is the copper is displaced by iron and form iron sulfate solution, which is in light green in color. Along with this, you will get copper also. And zinc also, here zinc, this copper is displaced by zinc and form as zinc sulfate plus copper. And here also this copper is displaced by lead and form lead chloride plus copper. And this is the example for the displacement reaction. And come to your double displacement reaction. In this double displacement reaction, we are taking sodium sulfate. When it is react with the barium chloride, it will form barium sulfate plus sodium chloride. Means here two groups are atoms are displaced. So this is we called as a double displacement reaction, in which what happens here, two different ions or group of atoms in the reactant molecules are displaced. It is called as double displacement reaction. Here sodium sulfate, now you see this is a sodium sulfate. This sodium reacts with the, right, this sodium reacts with the chlorine and this barium reacts with the sulfate. NaCl, you will get 2 NaCl. Barium sulfate is a white color precipitate you will get. So precipitate you suggest with arrow mark also, right? Sodium sulfate, when it is react with the barium chloride, it's an aqueous solution, so it will form white color precipitate. So what is the precipitate color? It is white PPT you will get here. Okay, along with this you will get NaCl solution also, and this is also example for precipitation reaction. Okay, so move on to the next reaction. It is oxidation and reduction reaction. The process of addition of oxygen to a substance or removal of hydrogen from a substance is called as oxidation reaction. Oxidation reaction means addition of oxygen or removal of hydrogen. Now you see in this example, the copper is oxidized, means copper we are taking in presence of oxygen, we are heating the copper. This copper color changes to black color, this due to formation of copper oxide, CuO, right? The process of removal of oxygen from a substance or addition of hydrogen to a substance is also called as reduction. Now in this reaction, when you observe here, so copper oxide is reduced. So removal of oxygen we called as what? Reduction. So this the copper oxide is reduced and the hydrogen gas is oxidized. Okay. So removal of oxygen is called as reduction. So copper oxide is reduced to copper. Addition of hydrogen to oxygen, then hydrogen gas becomes water, H2O. So this is oxidized. Hydrogen is oxidized to H2O. In which reaction, oxidation, reduction, both are taking place, and such type of reactions we call as redox reactions. Okay, what type of reaction it is? A redox reaction, in which we are seeing both the reaction, oxidation as well as reduction. Such type of reactions we call as what? Redox reaction. And come to your, the next one is, now you see the reaction in which oxidation reduction takes place simultaneously. The reactions we called as what? Redox reaction. Here copper oxide is oxidized to copper. Hydrogen is copper oxide is reduced to copper. So this is removal of oxygen is taking place here. So there is no oxygen here. Means we removed oxygen from the copper oxide. So this copper oxide becomes copper. means this is the reduction reaction. Copper oxide is reduced to copper. So now you see H2. When you add this oxygen, it will become H2. So it's addition of oxygen. So it's oxidation reaction. So hydrogen is oxidized to water, right? So here also when you observe these reactions, Fe3O4 when it is react with the hydrogen gas, it will form iron plus water. So Fe3O4 removal of oxygen is taking place. Here we have the oxygen, here we don't have oxygen, right? So Fe3O4 becomes Fe. So this reaction we call it as a reduction reaction. Fe3O4 reduced to iron and hydrogen gas is oxidized to water, right? Addition of oxygen is taking place now. And precipitation reaction. Already we discussed, and this reaction is also we call it a double displacement reaction. In this sodium sulfate barium chloride, when you add this, you will get white color precipitate, that is barium sulfate and sodium chloride also. Such type of reaction we call it precipitation reaction. So in this precipitation reaction, chemical reaction which involves formation of water insoluble precipitation is called as precipitation reaction. And this is example for precipitation reaction also. Exothermic reaction means the reactions in which heat is evolved is called as exothermic reaction. Example for the exothermic reaction is burning of natural gas. So natural gas is methane, right? And also we call it CNG gas. Compressed natural gas also consists of methane. When you burn in presence of oxygen, it will give carbon dioxide, water, and also some energy. It liberates some energy. And such type of reaction is called as exothermic reaction. And one more example is the decomposition of vegetable into compost is also an example of exothermic reaction. Next one is respiration. Okay, in respiration what will happen? So when you are inhaling the oxygen, so this oxygen combined with the hemoglobin, right, and it going to the cells, right? In the cells there is a mitochondria where this respiration reaction takes place, where the glucose burns in the presence of oxygen. It releases carbon dioxide, heat, and energy. Okay, such type of reactions we call as exothermic reaction also. In this, what is happening here is glucose is react with the oxygen and form carbon dioxide, water, along with some energy also liberated. Now you see endothermic reactions. Reactions which occur by absorption of heat are called as endothermic reaction. Means we are giving the heat to it. Because of that heat, this decomposes into several substances. Already it is also example for the thermal decomposition reaction and also example for the endothermic reaction. Here iron sulfate, when it is absorbed the heat, it decomposes into three substances: Fe2O3, SO2, and SO3. Here calcium carbonate, when you decompose in the presence of heat, it by after absorbing the heat, it decomposes into two substances, that is calcium oxide and carbon dioxide gas. Okay, next one is rancidity. Rancidity means the process of slow oxidation of oil and fat. Okay, here oil and fat oxidize in presence of oxygen. So whatever the oil and fat present in the food material resulting in the change of smell and taste is called as rancidity. Then how do you prevent this rancidity of food can be prevented? So how do you prevent this? By keeping food materials in airtight containers and refrigeration of cooked food at low temperature, packing of food items like potato chips in the packs containing nitrogen gas instead of air. It prevents oils and fats from the reacting with air. Already you have observed that the potato packet chips it's filled with some air. So what is the air present in that? Nitrogen gas is the inert gas. It won't react with the potato chips. Okay, so avoid keeping the food and food material in direct contact with the air. So by adding antioxidant agents like BHA, BT-related hydroxyl will also, this is a prevention of the reaction between the oxygen and the food items. We are adding this BHA. Okay, so in this way we can prevent the rancidity. So one, you have to keep the food in refrigeration, or also you have to keep in food in airtight containers. Okay, so then how do you pack the food items? While inserting the gas, what is the gas? You have to introduce your nitrogen gas. Nitrogen is a inert gas, right? By adding antioxidants also, we can prevent the rancidity. Then corrosion. Corrosion means the metal is and converted into its natural state. Means metal becomes metal oxides or metal carbonates or metal sulfate while reacting with the oxygen or water or some chemical substances present in the atmospheric air. Okay, for example, what is the corrosion? The phenomenon in which metals are slowly eaten away by the reaction of air water chemicals present in the atmosphere is called as corrosion. Then so some examples are there here: black coating on silver and green coating on copper is example for the corrosion, and rusting of iron also is due to corrosion. So how we can prevent this rusting or corrosion? By applying the paint on aeronautics. Rusting can be prevented. Paint does not allow oxygen and moisture to come in contact with the surface of iron. And this is about yeah, this is up to here we completed. So here we have the activities. Some activities are there. So your activity, first activity, in this first activity, what we are doing, we are taking the magnesium ribbon. When you burn the magnesium ribbon in the presence of oxygen, it burns with the dazzling white color, and also it forms the magnesium oxide powder. And what are the observations we can write here? It changes state from the hard metal to powder. Okay, magnesium is a hard metal. After reacting with it, comes to the powder in powder form. Okay, converted into powder form. And also it is example for endothermic reaction, and it is combination reaction. The two reactants are combined and form a single product. And also example for the combination reaction. When you observe here activity 1.2, in this is also this is also example for the precipitation reaction. So in this, what we are doing here, we are taking the lead nitrate aqueous solution. To this, we are adding the potassium hydride aqueous solution. When you combine these two, so what will you get here? You will get here lead iodide. What is that? Lead iodide, PbI, and one more solution is what? Potassium nitrate. This lead iodide is a yellow precipitate you will get here, and KNO3 is the aqueous solution. So in this, what happened? What you observe here? It changes state from the liquid to solid. Here the liquid is converted into solid. And this is also example for the double displacement reaction, and also we call it as precipitation reaction. And these are the observations from this reaction we can observe, right? And next reaction is, which gas will evolve when zinc metal reacts with the dilute hydrochloric acid? How will you identify the gas? Okay, when you take zinc granules, just you add the HCl, dilute HCl, then we can observe some air bubbles are coming to it. Right? What are the air bubbles are there? So what are the air bubble due to liberation of hydrogen gas, right? When zinc granules are added to the HCl aqueous solution, that HCl dilute HCl, it will so because of this reaction, you will get here zinc chloride aqueous solution. Here liberation of hydrogen gas takes place, and also it liberates some heat also, right? And so what are the observations from this activity we can write here? Evolution of hydrogen gas evolves with a pop sound upon a burning candle. Now here hydrogen gas is evolving during this reaction. How do you test this hydrogen gas? When you take burning candle nearer to it, the burning candle burns with some pop sound, right? And this is an indication of the liberation of hydrogen gas, and also it is example for exothermic reaction. And oxidation reaction has hydrogen is removed, and also we can call it as it is also example for the oxidation reaction, which the hydrogen we are removing from the HCl, so it converted into hydrogen, right? And it is also called as a displacement reaction. Here hydrogen is displaced by zinc. Okay, these are the observations we can write from this activity. And the next activity, we have here activity 1.4. In this, what we are taking here, we are taking the dry calcium oxide powder. To this we are adding the water, and this calcium oxide water combine and form as calcium hydroxide. What is that? Slackleite, right? You will get slackleite, and along with some heat also liberated. And this is also example for the combined reaction, and during this reaction some heat is liberated. And this is the reaction is the example for the exothermic reaction and combination reaction. Okay, so move on to the next one. What happens when calcium hydroxide reacts with the carbon dioxide? Okay, calcium hydroxide, when it is react with the carbon dioxide, and also it is of how do you test the carbon dioxide? Okay, so in the last reaction we get the calcium, for when you heat the calcium carbonate, you will get calcium oxide and carbon dioxide. Then how do you test this carbon dioxide? This carbon dioxide, when you pass into the lime water, and you will get white color precipitates due to formation of calcium carbonate. And this is also tested for the CO2. Okay, when you pass more excess carbon dioxide, when you pass to it, then what will you get here? This excess carbon dioxide reacts with calcium carbonate solution plus water and form a one soluble substance. What is that? Calcium bicarbonate. Okay, when you pass the excess CO2 to this, okay, this calcium carbonate, the excess CO2 react with the calcium carbonate and this water combination. Okay, this excess CO2 react with these two and form one soluble compound, right? Calcium bicarbonate. This is a soluble compound you will get here, right? And this is also example for the testing of CO2 gas, right? Now, next one is, what happens when ferrous sulfate crystals are heated in a dry boiling tube over a burner? Now you see, this is the activity, next fifth activity here. In this activity, what we are doing here, we are taking iron sulfate. Just you are giving some heat, and this iron sulfate decomposed into Fe2O3, SO2, and SO3 gas. Okay. So when you take iron sulfate in the test tube, when you are heating with the burning flame, Bunsen flame, or then what will you get here? You will get Fe2O3. What is the color of the Fe2O3 you will get? That is rust. What is the color of the rust? Already you know that is brown in color, right? Along with this, you will get sulfur dioxide and sulfur trioxide. Now you see the green color substance, when you decompose in the presence of heat, it converted into brownish black color. Already you know that. What is the color of the rust? That is brownish black. And your harmful poisonous gas also you will get sulfur dioxide and sulfur trioxide. So what are the observations we can write here? So we can observe some pungent smell. It is due to the burning of sulfur dioxide, and this is also example for the thermal decomposition reaction, and also we call it as endothermic reaction. Here heat is absorbed by the FeSO4. Now this is also example for the thermal decomposition endothermic reaction. In this we are taking the lead nitrate salt. Okay, when you heat this, it will convert it into lead oxide, and also it liberates some nitrogen dioxide. What is the color of the nitrogen dioxide? Brown color. Brown color fumes you will get, and also oxygen also liberated. Then how do you take this oxygen? When you take burning candle nearer to this, the burning candle burns with bright flame. Okay, and also here one brown color fumes also we are getting in this reaction. Okay, the brown color smell is due to brown fumes are due to liberation of the nitrogen dioxide. Okay, and also it is example for the thermal decomposition reaction, and also it is we called as endothermic reaction. Is it clear everyone? Now electrolysis of water. This is the electrolytic decomposition reaction. In this reaction what we are taking here, when water is electrolyzed, hydrogen and oxygen are emitted. Okay, so water we are taking, we are doing the electrolysis. At cathode you will get hydrogen gas, at anode you will get the oxygen gas. And when you what are the observations we can write from this activity? Volume of hydrogen gas is twice the volume of oxygen. It is very important. The hydrogen volume is 2 times more than the volume of the oxygen. Why? Because here 2 times of hydrogen gas we are getting here compared to the oxygen. One of the gases catches fire and burns with the pops, indicating that is hydrogen. How do you test the hydrogen? Same, the hydrogen which gives the pop sound with the burning candle, so which is presence of the hydrogen. And how do you test the oxygen? Oxygen is a gas. A candle burns brightly, so which indicate that it is the oxygen. And this is also example for the electrolytic decomposition reaction. And one more activity we have your photolytic decomposition reaction. So in this we are taking the silver chloride. What is the actual silver chloride color is white in color. When you keep this for sunlight for several times, then you will get a gray color because of formation of sulfur, and there is a liberation of the chlorine gas also. And this is also example for the photolytic decomposition reaction. And next activity we have here iron. When it is reacted, already we discussed this, and this is also example for the displacement reaction. You are taking iron nails and making copper sulfate solution. What is the color of the copper sulfate solution? Blue in color. So keep iron nails for 1 or 2 days, and this iron this copper is displaced by iron and forms FeSO4. Then solution, the blue color of the solution slightly changes into light green, and finally converted into thicker green due to formation of FeSO4 plus copper. Here color changes from blue to green due to formation of iron sulfate, and it also is example for the displacement reaction, right? So next reaction activity 10 here. So in this reaction, when you add aqueous sodium chloride to sodium sulfate, and what will you get here? You will get barium sulfate, precipitation, and sodium chloride. Okay, the barium sulfate is a white color precipitate you will get. So what is the type? What are the observations we can write it is? And this is an example for the double displacement reaction, and also we can call it the precipitation reaction. Here we can observe the white color precipitate is formed due to formation of barium sulfate molecule, right? Next one is, why does copper acquire a green coat when exposed to air for a long time? Okay, we are not burning this copper, right? We are not giving heat, right? Just you are keeping for some several days or several years. Then this copper, when it is reacting with the water and oxygen and carbon dioxide, which are present in the atmospheric air, and these are the atmospheric gases also. So when this copper react with the water, oxygen, and carbon dioxide, and this copper converted into copper hydroxide, CuOH taken place, and CuCO3. Combination of these two will give the green color, right? So next one is, why does copper powder turn black when heated? When copper, you take the copper granules and heat it for several days, several times, and this copper burns with the atmospheric oxygen in presence of heat, and it will convert it into copper oxide, which is in black in color. And what are the observations we can write here? Copper oxide formed due to the combination of the copper and oxygen. And here oxygen, when copper oxide is formed, what is the color of the CO? That is a black in color. And this endothermic reaction, why? Because we are giving the heat to this copper. And oxidation reaction also we call also oxidation reaction. Why? Because the copper is combined with the oxygen, right? It's addition of oxygen and also called oxidation reaction. Okay, so this is your chemical reactions and equation. Thank you for watching. Please subscribe.